Record. All right. Well, thank you so much for joining us today, Dr. Clinton. We have been chatting. Sorry for those of you that have been listening to us chat. So I would like to, I'll be helping to moderate the questions towards the end. So if you, as participants, if you have questions, please feel free to put them in the chat and I will assist with that. An introduction for our guest presenter today, Dr. Stephen Clinton is a medical oncologist specializing in prostate cancer. He comes to us today from the Division of Medical Oncology at The Ohio State University, received his medical degree and PhD in nutrition from the University of Illinois College of Medicine in Urbana, with residency in the internal medicine at the University of Chicago Hospitals and medical oncology fellowship at the Dana-Farber Cancer Institute in Boston. His expertise encompasses the full range of prostate cancer care from prevention to advanced metastatic disease. And in addition to his clinical work, he serves as the co-leader of the Molecular Carcinogenesis and Chemoprevention Program at the OSU Comprehensive Cancer Center, where his research is dedicated to prostate cancer prevention and therapy, as well as projects focusing on diet, nutrition, and lifestyle for cancer prevention and survivorship. The last bit that I'd like to highlight before I turn the mic over to Dr. Clinton is that much like in our division, Dr. Clinton's studies are often conducted in collaboration with scientists and other disciplines at The Ohio State, such as food science and agriculture, in a coordinated crops to clinic research effort. So we look forward to your talk today entitled Diet, Nutrition, and Cancer, Strategizing for Impact. Let us give a warm welcome to Dr. Stephen Clinton.
All right, thank you. It's a privilege to be here, even if it is by Zoom. We were on a, how should we say, physician travel ban until a few weeks ago. And by the time they lifted this, I just wasn't able to reschedule my Wednesday and Friday clinics to make a drive out there. So we're going to do this by Zoom. And we have a lot to do today because I picked a topic that you could talk on for a week. So there lies the challenge. Firstly, let me see if I can get this to move. There are no disclosures. There are many opinions, some of which you'll hear today. Now, this is a big picture talk. And this is the first time I've tried to do this big picture talk at a land grant university that actually has a nutrition program. I was asked to give talks like this to cancer centers that are different types, like Memorial Sloan Kettering, or universities that are not historically land grant universities with nutrition departments. But yet the clinical people want to know something about this field of diet, nutrition, and cancer. So I've modified this a little bit, and I really want to try it out on you folks today to see if this is at all useful or helpful to you, to kind of go through this high up, big picture overview. So let's move ahead. The cancer cascade. I think we all appreciate that as we age, there's a greater risk of cancer. There's a role for prevention in this space, screening, early diagnosis, therapy, and survivorship. So we've kind of divided this cascade into those components. And when you look at diet, nutrition, and fitness, the space where we have our greatest potential for impact is in prevention, during therapy, and during survivorship. Now, let's break this down even further. And we will talk a little bit about these different components. As you can imagine, the prevention space, the prevention space, the main goal is to safely reduce and delay cancer incidence. During therapy, we want to make the treatments work better or increase efficacy, enhance safety, enhance quality of life, and reduce the acute toxicity from the treatments. During survivorship, we want to reduce long-term toxicities, and many of our treatments have these kinds of complications, and of course, reduce mortality that's related to the treatment. We want to enhance quality of life and physical performance. We want to reduce cancer recurrence and reduce the risk of new cancers. Now, within this space of prevention, we have the public health approach, which really targets the whole population. So the one size fits all approach. But increasingly, we're going to be targeting individual risk, where we focus on those that are greater risk due to a family history, genetics, inherited genes that we define as high risk, pre-malignancy such as carcinoma in situ, or exposures. For example, we have studies here ongoing in the high-risk lung clinic of smokers. Now, during therapy, it really gets complicated because there are a lot of treatment and host and disease-specific issues. Therapy these days in cancer is surgical, chemotherapy, radiation, hormonal, immunological, biological, and multiple combinations. There are literally thousands of treatments in the medical oncology space these days. Many of these are specific for the type of cancer, they're specific for the organs, and there are so many host factors such as genetics and other issues that impact these outcomes. Now, go up to this survivorship in the green bars. We know that there's a little bit of a back and forth dynamic there. Some people fail and go back into therapy. Some people only live a short period because not all cancer treatment is successful. And indeed, that whole space of how to support people who are ultimately destined to pass away from their disease, how nutrition can be integrated in supportive care is a whole field of its own. And I'm not going to really talk about that today. So we want to talk more about long-term survivorship, which again, the goals there to prevent recurrence of disease, prevent second primaries, because one of the, for example, if you've had one breast cancer, there's a high risk of having a second primary develop over time. Many people are at risk of a second cancer, either due to the treatment that they received or due to a genetic predisposition that they may have. We want to reduce organ toxicity and comorbidities. Many individual factors fit into this, and goals here are longevity and quality of life. So this is a big slide with lots of information, and I want to highlight that over our history, 98% of the research has been on the prevention side, particularly focusing on public health guidelines or goals. But the whole future for us and why there's just so much to do for all the students and young folks in their early part of their career now in this area of personalized precision nutrition, which is going to be very relevant to each of these categories. Now, I throw this in. You folks will know some of this, but a lot of people at cancer centers really don't, particularly those in the medical profession. There's a reason why I'm so optimistic about that, and that is the historical precedents that we have in nutrition. And I have to begin for a lot of people in medicine and nursing just by this simple question: what is a nutrient? And I'm one for precision in language, and so I like people to use language very precisely. So a nutrient is a chemical or element that is essential for health, growth, function, and there is a deficiency syndrome defined and reversed by repletion of the nutrient. That is the definition of a nutrient. And we know in nutrition that this includes water, energy, multiple essential amino acids, certain fatty acids, minerals, and vitamins. And thankfully, the National Academy of Sciences since the 1940s has been very active in taking on the role for the United States in defining DRIs or dietary reference intakes based on trials and studies that really depend on a dose-response relationship. Now, people have forgotten the profound impact that the science of nutrition has had on public health. And if you literally go back to the last century, you've got diseases like rickets. And back in 1920, 100 years ago, 75% of the children in New York City had rickets. Just think of that. Pellagra, characterized by skin, gastrointestinal, and neuropsychiatric manifestations, or the 3Ds of dermatitis, diarrhea, and dementia, was a top 10 cause of death in the South of the United States 100 years ago, and the #1 cause of admissions to what were called the insane asylums back in the 1920s. Huge impact on health. Iodine deficiency disorders such as goiter, cretinism, and then cognitive disorders were prevalent. Anemia, perhaps the most common nutritional deficiency, particularly in women, affecting 2 billion people worldwide, even today. And more recently, folate and neural tube defects were targeted. And science in nutrition led to implementation through food fortification of approaches that profoundly reduced the disease prevalence for these conditions. And it's been a remarkable impact on human health. And there is no doubt that we can do this same thing in the field of nutrition and cancer. Now, for those in the medical profession, I have to remind them, this is a very complex space. There are many, many factors to consider. Our diet is everything that we consume, from nutrients, alcohol, non-nutrient, natural chemicals. The food is a vehicle for other substances that are pollutants that impact cancer, whether they be industrial or synthetic, or due to storage conditions like aflatoxins and mold, or added to the food during processing or cooking. And more recently, we have issues related to microbes, whether it be H. pylori and stomach cancer, or probiotics that we're actually consuming as a food. So it's very, very complex with lots of variables to consider. One thing that I like to remind people, phytochemicals are not necessarily nutrients other than provitamin A, carotenoids, etc. They are chemical compounds produced by plants. They can have biological functions in the plant or they wouldn't be there. And many of them are related to growth, reproduction, and defense against various pathogens and predators. But they're not nutrients because there's no deficiency syndrome. So don't call them nutrients. They can be bioactives because they have biological impact in mammals, and they have a diverse array of interesting chemical classes. Just the other day, we were doing a seminar here where a young man was giving a seminar as a potential faculty candidate, and he probably used the word nutrient 50 times in the talk for plant components, none of which are nutrients. So anyway, I'm going to send him a little email just to help him out on that. I'm not going to talk about carcinogens in the food supply today, other than to remind you that there is science in this field. The data in that area is reviewed by IARC, or the International Agency for Research on Cancer, as well as our National Institute of Environmental Health Sciences through many reports. It is then up to the USDA and FDA, based on congressional support, to create policies that reduce carcinogens in the food. And this had its origin really of banning carcinogens in food way back in 1958. And you should remember this, the Delaney Clause, which is very, very important. We're not going to talk much about the supplement industry today, where I just put a little bit of my own opinion there, minimal science and minimal policy. And just to remind everyone that this is a $140 billion global industry. And 75% of Americans are taking supplements. And 20% of people even will admit in surveys to be taking a supplement in place of a recommended drug to treat some health condition. And there are over 14,000 different manufacturers in the US with very significant lobbying activity. So it's a big deal. I'm only going to highlight one point on here, and that is that the safety and toxicity for supplements, unlike drugs, the burden of proof is on the FDA to prove that a product is not safe or toxic before it is removed from the market. And there is no requirement for a supplement on the market to have proven any kind of efficacy. This is exactly the opposite of a drug that you would use in the medical model. For our patients in the clinic, thank goodness for the Office of Dietary Supplements, where I can refer our patients to any number of dozens of supplements people take. And I remind them that the buyer has to beware when it comes to this space. There's virtually no knowledge on how supplements interact with so many medicines that are used in cancer and how that may either impact the toxicity and the safety of the treatments that people are undergoing. So let's kind of go back to this cancer continuum and talk a little bit more about prevention, which of course in the long run is better than having to work on a cure. So we'll focus on this prevention space and the two what I call strategic approaches. And the first one is the public health model, which focuses on the population as a whole. It's a public service effort where the interventions that we would provide are defined by objective or independent evidence reviews that by specific committees and agencies to define population risk factors, define goals and guidelines that should be integrated into public regulations, policy, and allocation of resources for public education as how to eat better to reduce a cancer risk. Now, where I live every day is in this space of the medical model where precision and personalized nutrition has such great potential in the area of prevention. So how do we define individuals that will need very unique and very precise guidance? Well, it's going to be people with specific genetic syndromes. So there's no doubt in my mind that we will be able to refine and come up with very precise recommendations for people that have syndromes like BRCA for breast cancer, or Lynch syndrome that has colon and other cancers. So genetics and genetic cohorts where we need to do research to define optimal strategies for prevention are barely touched. And certainly there's virtually no phase 3 clinical trials to give us guidance. People with pre-malignancies and other biomarkers of risk and environmental exposures. As I mentioned, we're doing trials in the high-risk lung clinic right at this moment. So this is very much directed at the individual and will be driven by evidence-based clinical trials, guideline development, and then I'm going to put in a plug-in, our dietitians need more than anything these kinds of guidelines that lead to reimbursement so that their efforts in the clinic will be appropriately supported and valued. So we have tons of data on the public health model, not much in the space of precision nutrition. So let's go back to the public health model and just talk about how do we come up with the evidence. And historically, going back 120 years, there is a host of things that led to our ability to create guidelines. It began with the development of our nutrient discovery space. And for the first 50 years of the last century, several Nobel Prizes were awarded for discovery of the essential nutrients. By the 1920s and into the 1950s, there were a whole host of cancer models that were finally coming into play for experimental research. Finally, we started to see experimental diet and cancer studies where nutrition was being brought into play with the animal models. The work of Albert Tannenbaum at the University of Chicago in the 40s and 50s is a remarkable example of this. What was critical, though, was the development of human epidemiology or nutritional epidemiology. And this required agencies like the UN to develop and promote, and the World Health Organization to promote what are called cancer registries. Up until then, we really didn't know what were the cancer patterns around the world and in different populations. So we had to have cancer registries to define what actually is the cancer burden among populations. By the 1970s, you began to see the development of what we'd call analytic nutritional epidemiology with food frequency questionnaires and the ability to look at individuals, their dietary patterns and cancer risk, and the development of large cohort studies that we have benefited so enormously from and continue to do so. What was really important in epidemiology, though, was this effort to develop systematic reviews in the last 20 years. So the mathematical and biostatistical tools to do systematic reviews and to do it in the way to pool information and have stronger recommendations. And I'm really excited about all the work that's going on now in the area of dietary patterns. So for many, many decades, we've been very reductionist in our thinking. We want to look at fat, or we want to look at protein, or vitamin D, or we want to look at zinc. But really, there's so much to learn in this space of dietary patterns. Unfortunately, in this area of prevention, there's very little data from large randomized controlled trials. And that's something we desperately need. Now, once you have science and published data, there needs to be efforts to come up with guidelines. And I really say that in the US, this was spearheaded by George McGovern, one of the senators back in the 70s, who really put together a Senate report on diet, nutrition, and health in the United States. And this led to the congressionally mandated NIH and USDA efforts to create dietary guidelines for America that continue to this day and are the foundation for all, let me say, they should be the foundation for all US policies in the area of food and agriculture. Two great epidemiologists, Dole and Pito, who were instrumental in defining the relationship between tobacco and lung cancer, targeted nutrition by the 1980s. And their report, called The Causes of Cancer, suggested that at least 30% of all human cancer would be related to diet and nutrition. The National Academy of Sciences had an outstanding report in 1982. The World Health Organization in 1989, all focusing on diet, nutrition, and cancer. But these were trivial compared to the work of the AICR and the World Cancer Research Fund and their landmark first report in 1997 on food, nutrition, and the prevention of cancer. So who are they? You need to know who they are. The American Institute for Cancer Research, AICR, the World Cancer Research Fund, WCRF. These are philanthropic organizations. They depend on donations to survive. This began in 1982 in the United States and expanded to the UK and the Netherlands, and then ultimately to Hong Kong, which that effort has a bit been thwarted by the integration of Hong Kong into the Chinese government, but that agency there still exists. And the WCRF was defined in 1999 to integrate these efforts around the world. Now, the expert report in 97 was repeated in 2007, and the amount of published data by then was becoming enormous, and they proceeded to have what was called a continuous update report. Rather than reconvene a new committee every 10 years, they established a committee that continued to review data on various cancers in a continuous manner. This was again summarized in a large report in 2018. You can have access to all of these reports online at their website. The process is amazing. And whenever they're going to do a new report on a specific cancer, they organize a team, they schedule and plan a calendar to do the report. The protocols are defined. Those protocols and the systematic review then is reviewed by an expert committee in the biostatistical approach of doing systematic reviews and meta-analysis. Then they go ahead and complete the study and collect the data, which then is reviewed by a committee of diet, nutrition, and cancer experts to create what we call the evidence base and draw conclusions. And then this is translated into public health recommendations, and the WCRF will take this report to various governments to try to institute public health policies to reduce the risk of cancer. I have to give the greatest of praise to Teresa Norat, who at the Imperial College in London for many years was the one that focused on preparing the protocols and directing the process of the meta-analysis. And this has recently been turned over to Kostas Tasilis at Imperial College. These databases are available to investigators. Any one of you could be involved in looking at those databases should you find that of interest. And I have to say, one of the greatest privileges of my life has been working for the last decade and more on these continuous update panel reports. Now, in the end, what you have is an evidence matrix. And these are defined by critical set of criteria: the types and number of studies available, the quality of the data, making sure that you have studied heterogeneity and variability between study types, trying to exclude chance, bias, and confounding in the review of the data. And then here's where some of the basic science comes in. You know, is there known biologic gradient, but also evidence for mechanisms from the people that work in the laboratories, and how strong is the effect? And in the end, for any one cancer, whether it's breast, colon, prostate, pancreatic, there's a table that's created where the evidence is judged as strong, limited, or strong evidence that there's no effect. And then the data is put into an evidence table, and I'll share with you some of this. First of all, let me just say, here are all the different reports that have been put out. I didn't put the last couple in there that you can have access to online. But if you really want to dig into this, dig into the systematic review reports. There are 12,000 pages of data that you would find very interesting that support these summary reports that are published. So here's a colorectal evidence matrix. Strong evidence, convincing and probable for physical activity, whole grains, dietary fiber, dairy products, calcium supplements as reducing risk. Several things associated with higher risk: processed meat, alcoholic drinks, body fatness, adult attained height, and red meat. Many things fall into these limited suggestive space, and many fall into a limited no conclusion. Let's just look at some of the data and some examples of information that comes out of these reports. So here's some of our data from just looking at whole grains. Meta-analysis of whole grain intake, colorectal cancer for 90 grams per day, approximately 3 slices of whole grain bread. Here's an example of a forest plot. You can see consistency among large epidemiologic cohort studies where these were measured appropriately. And the overall relative risk is 0.8, or about a 17% reduction in risk for every 90 grams of whole grain consumed. Rather strong. Here's fiber, which of course is defined more chemically. And here's a whole host of studies on a forest plot. You can see some fairly good, consistent data, again, for fiber, for colorectal cancer, men, women, colon, or rectal separated. The data is very similar, about a 10% reduction in risk for 10 grams per day. And, 10 or less would be what the Americans typically eat, and 20 or more would be sort of a reasonable recommendation for Americans to try to achieve at this point. Fruits. Here's a very interesting example for colorectal cancer because it's a non-linear dose response relationship. So what you can see is that you get a nice decrease in risk as you go up to about 200 grams per day. And then beyond that, there's no additional benefit. It's basically flat. So it's a very interesting curve that we see for fruits. Here's the red and processed meat going to one of the analyses that gives you an increased risk. And you can see compared to a relative risk of 1, the epidemiologic cohort studies are largely showing a fairly consistent increase in risk, and that for 100 grams or 3.5 ounces of processed meat and red meat combined, you can see about a 17 to 19% average increase in colon or rectal cancer risk. Alcohol also showed a non-linear dose response risk for colon cancer. And you can see at the low end, up to about 20 grams or so, we're really not seeing a significant increase. So 10 grams of alcohol in one of those drinks, so you may be able to have a drink or two without dramatically increasing your risk of colorectal cancer. Here we move into exercise, which I'm trying to follow a little bit here and participate in our fundraiser called Pelotonia at OSU. And we can see that the challenge for exercise is defining the units. And in all of these studies, they're a little bit different. And often we're having to compare the lowest quartile or highest quartile of whatever the exercise measure is in that particular study. But there's a fairly good, strong, consistent reduction in risk for colorectal cancer for the highest versus for colorectal cancer combined. A little less clear when you just look at rectal cancer alone. So exercise for colon cancer seems to be a reasonably good thing to add to one's lifestyle. Body fatness, again, a non-linear increase in colon cancer risk as you go from what would be considered a reasonably healthy BMI and then start to gain in BMI. So certainly once you get up into the 27, 31 range, you're getting a very significant 15 to 30% increase in the relative risk of colon and rectal cancers. So if you look at this, you clearly can see there's a pattern emerging, and the American diet and lifestyle is not looking so good. So we have a lot of room to go in colorectal cancer. I just want to throw in another one for comparison. I picked endometrial cancer for a couple reasons. Strong evidence for body fatness, convincing increased risk. Physical activity, coffee may decrease. Glycemic load and adult height seem to be associated with increased risk. But I really mostly want to show you one figure, and this is the nonlinear dose response for BMI and endometrial cancer. And I want to remind people, we're looking at relative risk here, so if not, 15% or whatever, we're talking relative risk of twofold, threefold, fivefold, 500%. All right. This is a log scale. That is a phenomenally significant increase in risk for endometrial cancer. And based on that, the AICR WCRF predicts that 59% of US endometrial cancer cases, or 3 out of 5 cases, could be prevented by being at a healthy weight and being physically active. That's 29,000 cases per year that don't need to occur. That's an astounding finding. Now, overall, these efforts on all the different cancers are pooled together to come up with a public health one-size-fits-all package of recommendations regarding healthy weight, physical activity, diets rich in whole grains, vegetables, fruits, and beans, limit processed, highly processed foods rich in fat, sugars, and starches, reduced red and processed meat, reduce sugar, sweetened and refined sugar beverages, limit alcohol. There's not a lot of evidence that supplements reduce cancer risk. So eat a healthy diet, breastfeeding for mothers. And after a cancer diagnosis, they've kind of have this unfortunate need to make a statement that follow our recommendations if you can, because there's such a lack of data for cancer survivors. But this becomes the one-size-fits-all public health message. So these messages, I'm going to say to you, all of you, is they're mature, much like dietary guidelines for America. These are mature and are not going to change very much as we go forward. So we don't need to spend hundreds of millions of dollars focusing on this. We really need to move on. And one of the challenges for making these guidelines, and many people say, well, we have the guidelines, that's all we need to do. Well, unfortunately, the real challenge is seeing these move into public policy and actually see them implemented. And the WCRF has a program called Nourishing, where they actually will work with governments around the globe to try to impact public policy relating to label standards, having healthy foods in public institutions, restricting food advertising when they're related to unhealthy patterns, improve quality of the food supply through agricultural policy, etc. So you can see there are a lot of things you can do at the policy level that could impact healthy eating and ultimately have impact on health. And more than 260 government policy actions across 100 countries have been implemented based upon these public health guidelines. So the big challenge then is to seeing that these move forward actually and have an impact. And I'm just going to give you one example of how these things become a challenge. The WCRF did a literature review and systematic review on what we would call the determinants of weight gain, overweight, and obesity. I'll give you one example from that large report, focusing on sugar-sweetened drink consumption in children. As we all know, childhood obesity is now a huge problem and gotten worse with the COVID pandemic. So here is a meta-analysis of studies looking at various measures of a daily serving of sugar-sweetened beverage consumption in children, and almost a 50% increase in this meta-analysis for promoting obesity in children. So this is a really strong effect. And some governments have taken action on this. In some countries, they've greatly increased taxation on sugar sweetened beverages. One that you may remember, and here I title this, but try to make policy and implement. So if you remember, New York City a decade ago tried to restrict the size of sugar sweetened beverages sold in New York City. That immediately led to a massive effort by the Sugar Association with signage on buses and trucks all over the city. Don't let bureaucrats tell you what size beverage to buy. And they promoted this as protecting your freedom of choice. And, you know, when you look at some of these and you see that something like Mountain Dew, 290 calories with 19 teaspoons of sugar in a bottle of 20 ounces, it amazes me you can get 20 ounces of sugar dissolved or 20 teaspoons of sugar dissolved in that. But you can really see the challenge that we have when children are consuming products such as this. So the implementation part is really a huge challenge for our field, where there's a lot of politics that impacts policy and implementation. So let's talk a little bit about the prevention, therapy, and survivorship space. As you know, precision nutrition is now a high priority at NIH, and this is across all of the institutes. There was a kickoff meeting last year, and you will see a lot of RFAs and grant proposals coming out in the months to come. Now, we are now, when we talk about precision nutrition, in these spaces in the medical model, where science in the laboratory and population science is going to design or is going to define for us opportunities for phase 1, phase 2, and phase 3 clinical trials, with the evidence then being used to define guidelines. And in the cancer field, there are professional organizations like ASCO, and the most important one, the National Comprehensive Cancer Network, that define guidelines that are meant to inform clinicians all over the United States on what is appropriate treatment for cancer. And they have dozens and dozens of guidelines about cancer treatment. And I can tell you, I think there may only be one out of the dozens of huge guideline documents that they have for cancer that includes a nutritional recommendation, and that is for supplemental feeding for head and neck cancer patients who can't eat after their surgery, radiation, and chemotherapy. So it's a very, very sad commentary on where we are at this point in time. We need those guidelines based on evidence, and then that will lead to the government and its Center for Medicare and Medicaid Services approving that that guideline should be implemented and paid for through Medicare, which then usually means that insurance coverage will have to be paid for. This is the critical step that we need. And then these will need to be studied through implementation science and studied for impact. But it is so key to have that coverage and have dietitians in the clinic doing the work that they are trained to do for the benefits of our cancer patients. And I really always have to kind of come back and say, don't try to train a physician to do this. You need the dietitians. A physician's busy enough treating the cancer. They need the dietitians working as an integral part of the team to do this. Now, what are we going to test? And who are we going to test? These are the key questions. We've talked about targeting high-risk cohorts, whether they be cancer risk-defined cohorts or high risk simply because their diet and lifestyle is terrible. What are the strategies? We can focus on nutrients, foods, dietary patterns, and combinations. All of these are relevant for phase 1, 2, and 3 clinical trials. I'll just give one example of vitamin D that I'm interested in. This began with studies way back 20 some years ago from my friends Ed Giovannucci, Walter Willett. They didn't talk about vitamin D in this paper, but this relationship of how calcium and fructose alter vitamin D metabolism and was key to this publication. There's many other studies that have looked at prostate cancer risk and mortality around UV exposure. With greater sunlight, you have a lower risk. And a friend of mine that I collaborated with for a number of years on this, Jim Fleet, now at the University of Texas in Austin, we went through what I call the preclinical hierarchy, cell culture study showing vitamin D orchestrates anti-cancer gene expression in immortalized prostate epithelial cells, constitutive activation of oncogenes, meaning the more malignant the cancer is, the more you impair vitamin D signaling, which means we need to study vitamin D early in the cancer cascade, not late when it's almost over. We move to the animal models. We know that the vitamin D receptor modulates the ability of testosterone to promote proliferation and cancer cell survival. We know that we can change dietary vitamin D and affect those same outcomes. We know that if we knock out the vitamin D receptor, we reduce prostate cancer in the mice. And we know that vitamin D suppresses early carcinogenesis in models of the very first steps and stages of prostate cancer. So, what's the high-risk population? Should we be focusing only on people with low vitamin D status, of which there are many in the US? So we're working on designing this and hopefully having a phase 2, a multi-institutional trial up and running that would be a precursor for a large phase 3 trial. Now, let me just say a few words about food products for clinical trials. And in our Crops to the Clinic program at OSU, we've done this with tomato, soy, black raspberries. The secret of this is you have to make the food like a drug. You need to have it fully characterized, tested, stable, taste good, high compliance, and you might be able to get a grant funded in this space. People that think like pharmacists don't like this. They say it's too complicated. So you have to make your food as close to a drug as you can. Now, this is where the integrative effort is so important. We've worked with plant geneticists, we've done animal preclinical studies, we work with horticulture and crop science to harvest. We go to food science for developing a product, sensory testing, production, showing stability, analyzing for bioactives, and then we can bring this into clinical trials in humans to study safety, compliance, genetics, genetic effects on metabolism, bioactivity, and mechanisms of action. 2 products that are currently in phase 2 trials are a whole grain soy bread product in a prostate cancer trial, and a black raspberry nectar that is in a phase 2 trial of smokers and non-smokers looking at the oral microbiome. We really need the randomized controlled trials. Say a few things about survivorship. First of all, hats off to the WCRF for moving into what they call their transition phase, where they are looking at food nutrition on outcomes after a cancer diagnosis and doing systematic reviews and meta-analysis. The 3 big projects that are underway focus on breast survivorship, colorectal, prostate, and survival of childhood cancer. All very important. The first paper will probably come out shortly. This is on physical activity and health-related quality of life in women with breast cancer. And this was the first one because it was kind of a space where there's a lot of data because health-related quality of life is relatively easy to get compared to long-term mortality. So there were a multitude of studies. Here's one example looking at the health-related quality of life from a number of studies where quality of life is looked at by global tools, general health perception, physical functioning tools, emotional functioning, mental health, etc. And you can see in the forest plot, generally everything is to the right of the null line. So very positive finding in that space. We are finishing up a dietary and exercise trial in largely breast cancer survivors that is a very intense phase 2 trial of diet and exercise. This again was done in collaboration with our College of Agriculture with multiple components, including garden harvesting, motivational interviewing and coaching, individual as well as group support and education, cooking and skill development, and continual feedback, using as much as possible the technology that is available. And we did this at OSU's farms, which is really, we had 5 acres where people participated in gardening. We had our lecture hall for food preparation and other educational events. And here's just some of the initial results. So changing to a healthy dietary index score associated with the WCRF, AICR, we can see that any line above is a positive change in your diet score. The line below is no or a negative change. You can see the vast majority of people improved their scores. On our 6-month intervention, change in body weight, again, this is not easy to do, but you can see that by and large, we had good success in seeing our cancer survivors lose weight with this study. Multiple components of the diet were improved across the board, including clinical outcomes of weight, blood pressure, skin carotenoids, blood carotenoids, steps, and physical performance, such as the 400-meter walk, stair climb, grip strength, and quality of life. So metabolomics, microbiome, and fecal metabolomics are to come. So a lot of lessons learned from that. What you need is quality education. The setting matters. Doing this in a garden setting, I think, massively improved compliance and group support, people talking and working with each other, skill development, feedback, using technology. And I don't have time to talk about the maintenance. So again, what do we need in this space? Are randomized controlled trials supported by good science. And I will say thanks here to so many people that I just couldn't list on a slide, but I'll say a thank you to NIH. I love being on Dietary Guidelines for America Committee, the AICR, WCRF for more than a decade of working on their continuous update program, for the National Academy for being a part of the DRI committee for vitamin D, calcium, phosphorus, and of course to my home institution. So with that, I know that's a lot. Thanks for sticking with me for the hour, and I'm happy to take some questions.
Thank you so much, Dr. Clinton. So I will absolutely agree with Dr. Parks when she said an excellent overview, and I'm happy to see a few of my undergraduate students here for that. But I will looking through the questions. We'll start with Meg, who also had a comment that Cook County in Illinois also implemented that sugary soda drink tax, and it went over like a lead balloon. Not her words, my interpretation, but not very well. But her initial question was looking at the relationship with attained adult height and its increase of one's colorectal cancer risk. And
Yep.
I'll add on my little bit about that was also for another type of cancer as well. So could you speak to what that might be or the mechanisms there?
Yeah. So first of all, this is one of the things I wish didn't show up in these massive epidemiologic cohort studies, but it is consistently showing up in colorectal cancer and some others. And I think this has to do with the fact that whatever's going on early in life, where people are achieving a higher adult height, because you know that kind of is defined by everything that goes on in your youth up through puberty, that there is something going on that affects growth hormone, insulin-like growth factors, other hormonal patterns that perhaps epigenetically are modifying the DNA in various target tissues to make them more susceptible later on. But this relationship between higher adult attained height shows up in some of the breast cancer studies and others. Now, no one is going to recommend that you malnourish a child or a teenager just to lower the height so that you don't get a cancer, because look, your chance of getting colon cancer might only be a couple %, but there's a lot of other reasons why you want to have good nutrition during youth and teenage years.
Absolutely. Talia's question, it sticks along with the body composition. So she's asking, is it strictly looking at cancer risk in weight and BMI? So she was asking specifically, is it a body fat percentage or strictly BMI that impacts cancer risk more? And does that account for any racial differences in BMI, such as in Asian populations and the trends that we see there?
So the answer to that is, I'm glad you're going to study this, because every single one of those are great questions that need to be studied. And one of the challenges of epidemiologic data is that you may have height and weight in these cohort studies of 70,000 people, but you don't have percent body fat. You don't have other measures of body composition in a lot of those studies. So what you have in those large studies you can do meta-analysis on is incomplete data, but you have a huge N. You see what I mean? And so, you know, what we can say is limited. And so some of those questions are going to have to be studied more carefully in perhaps smaller studies that focus on mechanisms and things like that. And there's no doubt that people want to look at this in different ethnic populations. But as you may know, the bulk of cohort studies, when they were designed, are suboptimal in representing many of the minorities for lots of reasons. And so all of those are great questions, and all of them warrant research.
Excellent. So Dusty's got the next question that is in the chat, and it's switching more to the policy sections of your talk today. But her question is, if you have any ideas about how to affect public policy while battling lobbyists, for example, like Coca-Cola, do you think cancer risk from improper nutrition is enough to sway policy in a better direction?
Yep. Again, I'm going to have to punt and say, great question. And so, you know, when I was younger in grad school and I was working in the lab, I'm just going to give you kind of my transition intellectually in this space. You know, I went to work in the lab and do cell and animal studies. But when I got done with my PhD and I was talking to clinicians, you know, they didn't understand what I was doing. They weren't going to implement it in the clinic. And so at that moment, I kind of had this moment where I said, well, you know, they don't understand me, and I certainly don't understand what they're doing. So I got to go to school for another 10 years. So medical school, residency, medical oncology, and then pop out at the other end. And again, I was back in the lab doing a lot of laboratory stuff, but now I was skilled enough I could translate some of this into the clinic. Okay. And that became a focus. I figured if I can translate the lab stuff to the clinic and generate knowledge, that would solve the whole problem. So then what happens? I get on all these committees and I'm making guidelines. And then I'm having people come back at me saying, well, we have guidelines for dietary guidelines for America, but people are still getting more obese, unfit, and sicker. So dietary guidelines failed. Well, nothing could be more wrong. The guidelines are absolutely right. The failure is in creating policy at the government level that allows the guidelines within what we now have. It's a toxic food environment truly being translated for the benefit of the people. So now I'm dragged into this question that was just asked. And frankly, I'm not trained for it, and I'm too old to go back to get a degree in public policy. So you guys are going to have to figure this out.
I like that answer. I'm going to probably steal that line for some of my students when they have these really good questions. So one that perhaps you'll be more confident and comfortable fielding comes from Dr. Parks. So I'll read it. I'll let her have any follow-up questions if she has them. So her question was to ask you to talk about the studies of low carbohydrate diets before cancer treatment to improve treatment, or after treatment to reduce remission. So I'll let you talk on that. I'm sure she'll have some follow-up too.
Yeah. I mean, first of all, let's just sort of say, what do we mean by low carbohydrate diet? Now, carbohydrates, as we know, come in all kinds of forms, right? Some are complex carbohydrates, and some are partially processed starches, and then some are sugar. And every one of those is sort of a different question, right? Or is it all of them together that we reduce? And if we reduce them, what are we going to eat in place of them? Are we going to replace it with fat, or are we going to replace it with protein and fat together? And what kind of protein and what kind of fat? So when you get down to doing a clinical trial, to answer that question, there's about 50 variables you have to think about, right? And so I don't think we have what I would call enough studies that are comparable to one another, where you could do a meta-analysis to even begin to sort of say, for breast cancer patients that get a certain kind of chemotherapy in the adjuvant setting, you know, we just don't have enough data. And I doubt that you're going to be able to say that a low carbohydrate diet improves the outcome of all chemotherapy when there are 100 some different kinds of chemotherapy that are being used. So it's a complex space where specific, well-powered phase 3 trials are going to have to be done in order to create a guideline and have those integrated into practice. So I know I can't really answer that. Is it a worthy question to ask? It is. But you're going to have to create really well-designed, highly controlled studies so you know what's going on when you do that intervention in a very specific population with outcomes that you can measure.
She says, okay.
Okay.
I want to be I'll leave a few moments. Our new dean says 6 seconds is enough time to leave to see if anyone has questions. That's a fast 6, trust me. That was absolutely not 60 beats a minute. But I do want to be good stewards of everyone's time. Dr. Clinton, we really appreciate your talk today. It was very good. I'm so pleased to see some of my undergrads here, because it was just like you said, like Dr. Park said, an exceptional review. And I wanted to personally say thank you for all of the shout out to street cred for dietitians and the work that we do in the clinical space, because we are very proud of our program here. We have good clinicians that come out of it, and they're ready to work alongside researchers. So thank you so much. And with that, let's give him a warm send off for a nice day.
All right. Thank you. Good day.
Yes. Thank you so
you.
much.